Now let's consider interpretation of the z-score. Now generally, the z-score you get, that the value of the z-score will tell you whether the score is below average, above average, or an average score. Now whenever you get a z-score which is greater than 0, since on the z-score scale 0 is the mean, whenever you get a z-score which is greater than 0, then what it means is that the item of which we are to determine its relative standing in the data set is an item or an element greater than the mean of the data set. Should I go, boss? Sorry. And meaning, can I go back to that point? What it means is that in reality, the element whose relative standing we are to determine is an element or is a score which is above or greater than the mean, or which is above an average. Example, let's say you organize a quiz for your students, and at the end of the day you had a z-score of 1. What it means is that comparing the student score to the mean of the data set, it will be about 1 standard deviation from the mean. Meaning the student score is above average. Likewise, if you had a z-score of 2, it means the student's score is about 2 standard deviations from the mean of the scores of the students. And for that matter, the student's score is above average. Let's consider the second situation. When it happens that the z-score obtained is less than 0, then what it means is that the item or the element in the data under consideration is less than the mean of the whole data set. In other words, it is a score or an element below the mean of the data set, that's below average score. In reality, let's say you conducted an exam for your students, let me say your pupils in this case, and after calculating the z-score, you had -1. What it means is that the student's score is about 1 standard deviation below the mean. Hence, the student score is below average. In the second situation, let's say you had a z-score of -2. What it means is that the student's score is about 2 standard deviations below the mean of all the scores in the class. And for that matter, the student's score is below average. Now, in the third situation, when you get a z-score being equal to 0, then the item in the data set is equal to the mean of the whole data set. For example, you organize a class test, and don't forget, when it happens like this, we say the student score or the item is an average score, or you can simply say it's average. For example, you organize a class test, and after calculating the z-score, you had 0. A z-score being 0 means the item is equal to the mean, since a number minus itself is always equal to 0. And for that matter, we say that the student score is an average score. Now let's consider some solved examples. A student received a mark of 84 on a final examination in mathematics, for which the mean mark was 76, and the standard deviation was 10. In physics, the student had a mark of 82 with standard deviation 16. In physics, the student had a mark of 90 with standard deviation 16, and the mean mark of all the scores is 82. So if we are asked, in which of the subjects was the student's relative standing higher? First, we need to find the z-score of the various subjects. So if you consider the z-score of the students in mathematics, it will be z equal to 84 minus 76 all divided by 10. That is, 84 is the score of the student, and 76 is the mean score of all the mathematics scores of the students, and 10 is the standard deviation. So with this calculating, we will end up getting 0.8. Then when you consider the z-score for physics, it will be 90 minus 82 divided by 16, which gives us 0.5. Now comparing the two z-scores, you see that 0.8 is a positive mark, or is a positive value, and 0.5 is a positive value. So what it means is that the student's z-score of 0.8 is about 0.8 standard deviations above the mean. Then when you consider that of physics, the 0.5 is about 0.5 standard deviation above the mean. Hence, the student's performance in mathematics is of higher standard than that in physics. Even though if you are considering the raw score, the student's score in physics is higher than that in mathematics. Now, let's consider these few points. When the z-score is positive, you consider the one with the highest value. In the case of exam scores, it means the student's relative standard is higher than the one which is less. In the case of negative, all the values being negative, the one with a higher negative value performed poorer than the one with a lower negative value. If it happens that you had one z-score being positive and the other being negative, then definitely the one with the positive is of higher relative standing than the one with negative. Of course, if you got all of them to be 0, it means they all performed equally. Now, these are some few questions for you to go and try. Question 1. In an end of semester exams, the mean mark of 150 students in statistics was 78. And the standard deviation was 8.0. However, in algebra, the mean mark of the student was 73 and standard deviation was 7.6. If a student scored 75 in statistics and 71 in algebra, which of the courses was his relative standing higher? Question 2. In a quiz, the marks obtained by some students are 6, 2, 8, 7, and 5. Convert the marks into standard scores and interpret your results. Question 3. A national achievement test is administered annually to some teachers. The test score of 100 and a standard deviation of 15, if J, who is one of the teachers, had a Z score of 1.20, what was her score on the test? We have to go and try these questions. Now let's move on to the second entity under the standard scores. That's the T-score. The T-score ranges, or its scale ranges from 10 to 90 at intervals of 10. The average of the T-score is normally 50. However, we normally consider a score between 40 to 60 to be average. What it means is that any score below 40 is considered as below average score, and any score above 60 is considered as above average score. Mathematically, the T-score is normally given by T equal to 50 plus 10 Z, where the Z here is the Z score of the data set, and the T here is the T-score. What does that mean? From this equation, it can clearly be stated or realized that the T-score normally depends on the Z-score for its calculations. Apart from that, there's nothing different, because all of them serve the same purpose. The interpretation and everything is almost the same. Just that the difference, the values for below average, average, and above average are different. But they all give the same interpretation in respect to the relative standing. Now let's consider the third standard score, which is standard 9 score. The standard 9 score is at times called star 9 score or star 9 scale. Now the standard score ranges or takes the values from 1 to 9. From 1 to 9. With 5 being the mean of the data. With the standard 9 score, the scale is divided into 3 main sections, with the first section being from 1 to 3, the second section being from 1 to 6, and the third section being from 7 to 9. Whenever a student scores or an item falls within the first section, that is 1 to 3, that item is classified as below average. When an item falls within the second section, that is 4 to 6, that item is classified as an average item. And when an item falls in the third section, that is 7 to 9, it is classified as above average item. So what it means is that if, for instance, a teacher organized a class test and scored the marks over 10, anybody who scores between 1 to 3 will be classified as below average student. And anybody who scored a mark between 4 to 6 will be classified as an average student or an average score. Then anybody who scored above, or let's say scored a mark between 7 to 9, that person will be classified as what? An above average student. Don't forget, all these scores are in relation to the standard 9 scores. So with this, we bring the whole lesson to an end today. I hope you enjoyed the lesson. Thank you.